Hi, everyone. This is my course project for the Machine Learning Foundations for Product Managers course, which is to build a model to predict the electrical energy output of a combined cycle power plant. Given that there are a fixed number of features used to determine a target, this seems to call for a linear model. We want to predict the net hourly electrical energy output, or PE. Understanding the goals of a combined cycle power plant, we want to try and reduce spikes of electricity need and be as consistent as possible to match customer needs. Being off by a lot one time can be much worse than being off by a little every time. Therefore, MSE seems like the right metric to use in comparing the performance of different models. Initially, I decided to use all the features outlined in the data: temperature, ambient pressure, relative humidity, and exhaust vacuum. I decided to use Excel as my model building platform. I manually split the data set roughly into a 70-15-15 setup: 70% for training, 15% for validation, and the remaining 15% for testing. We have a good amount of data, so I chose to use a fixed validation set. I first started with a multiple linear regression model and used Excel's data analysis tool to build and provide analysis data on the training set. I noticed that the multiple R, R square, and adjusted R square values looked pretty good, but the standard error was not optimal with a value of 4.49. I also noticed a good correlation between the features selected with PE values. But looking at the RH residual plot graph, I saw that the residuals spread more than the other feature plots. I then decided to try an alternative model by removing RH as a feature. The multiple R, R square, and adjusted R square values were only slightly worse than when RH was included, and the standard error value was also worse at 4.86. As a third model, I tried ridge regression and brought back RH as a feature. For this, I installed a free Real Statistics plugin for Excel. The multiple R, R square, and adjusted R square values were very close to the multiple linear regression model. In addition, the standard error was extremely good at 0.28. A lambda of 66.97 seemed to be the optimal point before the ridge trace graph showed convergent movement. The ridge regression model seemed to be the best one to use. I'm now going to share the Excel model that I decided to choose. You can see here that I have tabs that represent the different models that I tried, and I'm going to switch over to the ridge regression one that I decided to choose. And again, as you can see, as I described, the values for the overall fit here are pretty good, and I was blown away by the standard error number right here. And so what I did then was I continued to test this model. First, I validated it, and I saw that the MSC value was 23.25, which is pretty good in this case. And you can see that I used the formula that came with that Real Statistics package for ridge prediction to calculate or to predict the PE. Now, I was careful to use the values that were that the model was trained on, or I should say, use the model that was trained on the training data. And so that's where I'm getting it from, the tab that specifically trained that model. And so using that to predict the values when they're passed through for these other values here. I then continued this on the test data, and again, the MSCE was still pretty good at 21.02. And so this is the model that I ended up with. And as I said, and so that concludes my project. Thank you.